Welcome to the DIY Honda Garage channel. The trouble code P0325 indicates a malfunction in the knock sensor circuit for the 2008 to 2012 Honda Accord. The knock sensor plays a critical role in monitoring engine vibrations that occur due to detonation or knocking, which can harm engine performance and longevity. It is typically located on the engine block and connected to the engine control module, ECM, or powertrain control module, PCM. When the knock sensor detects excessive vibrations, it sends a signal to the ECM, PCM to adjust ignition timing and fuel delivery accordingly. If there is a circuit malfunction, improper signals may be sent, affecting engine performance. Thus, diagnosing DTC P0325 is crucial to ensure the vehicle operates efficiently and reliably. The primary component affected by DTC P0325 is the knock sensor, which is designed to monitor the engine's vibrations to detect knocking or detonation. This sensor is generally located on the engine block, ensuring it can accurately gauge vibrations. Its role is essential as it signals the engine control module ECM or powertrain control module PCM to adjust operational parameters like ignition timing and fuel delivery when vibrations are detected. This helps prevent engine damage and optimize performance. Additionally, the knock sensor communicates with the ECM, PCM via electrical signals, allowing the engine's performance to be regulated based on real-time data. If the knock sensor circuit is compromised, the engine may not perform at optimal efficiency. Several factors may trigger DTC P0325. First, the knock sensor itself may be faulty, leading to inaccurate readings of engine vibrations. Secondly, damaged wiring or poor connections can disrupt the electrical signals between the knock sensor and the ECM, PCM, potentially causing circuit malfunctions. Third, a failure in the ECM, PCM may occur. Although this is rare, it can lead to incorrect processing of signals. Finally, intermittent issues may arise, where the symptoms are not consistently present, often leading to confusion in diagnosis. Each of these components must be examined in detail to isolate the root cause of the malfunction. The symptoms associated with DTC P0325 can significantly affect vehicle performance. One common symptom is poor engine performance, characterized by a lack of power or responsiveness when accelerating. Additionally, users may notice increased fuel consumption due to incorrect fuel and ignition timing adjustments caused by the malfunctioning knock sensor. Another symptom is a rough idle, where the engine may shake or vibrate more than usual at a stop. Finally, the check engine light will illuminate, signaling that there is an active error code that requires attention. It is crucial for drivers experiencing these symptoms to seek diagnosis and repair promptly. In the first troubleshooting step for DTC P0325, it is essential to turn the ignition switch to the on second position. This action powers up the vehicle's electronic systems and allows diagnostics to be conducted. Before proceeding further, ensure that all freeze data and onboard snapshots are recorded. Freeze data represents the conditions under which the fault occurred and can be invaluable for diagnosing intermittent issues. Similarly, reviewing general troubleshooting information related to the error code will provide a framework for understanding potential causes and solutions. This preliminary step is crucial in establishing a good foundation for the diagnostic process. The next step involves using the Honda Diagnostic System, HDS, to clear the DTC from the vehicle's memory. The HDS serves as a comprehensive diagnostic tool specifically designed to interface with Honda vehicles. Clearing the DTC removes old codes, allowing for a fresh diagnostic assessment. Following this, it's important to start the engine. This should be done with caution to hold the engine speed at 3,000 RPM without load, either automatic transmission in park or neutral, or manual transmission in neutral. This step is crucial for conducting further tests and ensuring that the previous error code does not return immediately, which indicates a persistent problem. Continuing the troubleshooting process, hold the engine speed at 3,000 RPM until the radiator fan comes on. This condition ensures that the engine reaches operational temperature, which is necessary for tests related to engine components. Once the radiator fan activates, signaling that the engine has sufficiently warmed up, let it return to idle. This process helps to monitor the engine's performance under load and provides an environment for the components to react as designed. It is important to observe any irregularities during this step, as they can hint at the underlying issue related to the DTC. Next, hold the engine speed between 3,000 and 4,000 RPM for at least 10 seconds. This process creates a consistent operating condition for the engine and allows the knock sensor to accurately assess vibrations related to knocking. Consistent revs help test various systems under load, making it easier to determine if the malfunction persists. Upon completing this duration, you will prepare to check for pending or confirmed DTCs using the HDS. This step is vital as it tests the system under duress, ensuring any lingering issues are identified after initially clearing the codes. In this step, you'll check for any pending or confirmed DTCs using the HDS. This diagnostic tool provides detailed feedback regarding the vehicle's systems and can reveal whether DTC P0325 is active after performing the previous steps. If DTC P0325 is indicated, it confirms that the issue remains unresolved and further troubleshooting is necessary. However, if the DTC is not present, it suggests an intermittent failure. In this case, you should investigate for poor connections or loose terminals at both the knock sensor and the ECM/PCM. This step is crucial for determining whether to proceed with further troubleshooting or to identify external problems affecting the sensor's function. Once the previous steps have been completed, turn the ignition switch to the lock 0 position. This action is necessary to ensure that no electrical signals influence subsequent tests. Next, jump the short connector service SCS line with the HDS. Jumping the SCS line helps to perform diagnostics in a controlled environment by allowing for deeper testing of different modules without triggering certain systems. This step prepares the vehicle's electronic systems for detailed inspection of the sensor's wiring and connections. Next, disconnect the knock sensor subharness, which is typically a 1P type connector. Removing this connection isolates the sensor from the ECM/PCM, facilitating the next test. This step is essential to assess the integrity of the circuit and verify whether the problem originates within the knock sensor or the wiring to the module. Once the sensor is disconnected, you can conduct further checks on the wiring and connections to ensure they meet the necessary integrity specifications for proper function. Continuing the troubleshooting process, the next step is to disconnect the ECM/PCM connector C, identified as the 49P type. This action allows you to isolate the engine control module or powertrain control module in order to check the continuity of the circuit. The PCM is crucial in controlling various engine parameters, and any faults here can lead to issues like the one indicated by the DTC. By disconnecting this connector, you also reduce the chance of incidental shorts or incorrect readings when performing continuity checks on the wiring. In this step, you will check for continuity between the ECM-PCM connector terminal C47 and body ground. Establishing this continuity is vital as it confirms whether the wiring from the PCM to the knock sensor is intact and ensures that the electrical circuit can function correctly. Use a multimeter to perform this test. If continuity exists, it suggests that the wiring is sound, but indicates a short between the ECM-PCM C47 terminal and the knock sensor subharness. If there is no continuity, the next step must be pursued to diagnose potential wiring breaks or opens that might be causing the malfunction. Once the continuity check is performed, the results will dictate the next course of action. If continuity is present, it confirms that the wire linking the ECM-PCM terminal C47 and the knock sensor subharness is intact, and thus a short exists somewhere along the wire. The next step will be to carefully repair that short or any related wiring issues before proceeding with the tests. If continuity is not found, proceed to step 11, which involves checking another part of the circuit. This decision pathway is crucial for determining where the system failure lies and takes a methodical approach to ensuring the trouble code is accurately resolved. In this final step of troubleshooting, connect the engine wire harness C104 1P connector terminal to body ground utilizing a jumper wire. This temporary connection aids in verifying if the grounding is sufficient within the system. Addressing possible ground-related issues, which can cause erroneous readings, including malfunctioning sensors like the knock sensor. After making this connection, monitor the engine's performance and check for the reappearance of DTC P0325. If the code is eliminated, it indicates that there's a grounding issue that needs to be fixed permanently. Further diagnosis would involve either repairing the ground connection or replacing wiring as needed to ensure that the circuit functions as intended. After completing the troubleshooting and repair steps outlined, performing a final repair verification is essential. Start the vehicle and monitor its performance closely. It is crucial to check for the reappearance of DTC P0325 following repair efforts. Additionally, observe engine performance metrics during operation to ensure no unusual behavior is present. Running the vehicle under various conditions will confirm that the repairs made were successful and that the knock sensor circuit is functioning properly. This step not only ensures that the issue is resolved, but also contributes to the overall reliability and safety of the vehicle. Preventive maintenance can play a significant role in avoiding issues related to DTC P0325. Regularly checking the connections and wiring associated with the knock sensor and the ECM/PCM can help catch problems before they escalate. Additionally, using quality components during repairs and replacements is essential, as inferior parts may lead to recurring issues. It is advisable to establish a routine maintenance schedule that includes visual inspections and functional testing of critical engine components. By adhering to these maintenance practices, drivers can enhance the longevity and reliability of their Honda Accord's engine. In conclusion, DTC P0325 signifies a malfunction within the knock sensor circuit, which can lead to significant impact on vehicle performance. Identifying this issue begins with a comprehensive understanding of associated components, including the knock sensor itself, the wiring harness, and the ECM-PCM. Thorough troubleshooting, as outlined in the steps above, will help isolate the fault, whether it relates to the sensor, wiring, or connections. After repairs are made, both verification and preventive measures are necessary to ensure long-term vehicle reliability. By closely following the troubleshooting process and adhering to maintenance protocols, vehicle owners can effectively manage and prevent issues associated with DTC P0325. Please like and subscribe to the channel. See you next time.